Hello everyone, this is the video lecture for College Algebra, Math 1414, Section 4.2, Logarithms, or here just logs, I guess. Logarithms. Logarithms? I don't know, I think I spelled it right. Not that you can read that. So, what is a logarithm compared to exponential? And so we got y equal to b to the x. B is your base. X is your exponent. And then, so that's an exponential. If you're wondering, hey, what's that? That's exponential. And then we got y is equal to log base b of x. Let me write that out. Log base b of x. And this is a logarithm. So a lot of people have seen exponentials before. Not as many people have seen logarithms, or maybe you have, but really not done much with them. And that's fine. That's why you're here in class. So these guys right here are inverses of one another. They're inverses, okay? Again, reminder, what's an inverse? Well, we got exponential growth, let's say, and then we got our logarithm right here, and a inverse is along the 45-degree line, a mirror image. Okay. So I want to show you how I convert back and forth and stuff like that. So I'm going to just do this thing on the side, I guess. This is a conversion. Yeah, that's close enough. So we're going to do some conversion stuff. Let's just say I got 2 cubed is equal to 8. Is that a true statement? Yes. Okay, so I want to rewrite in log form. So what does it look like in log form? I got log base 2, and then I open these two parentheses up. And now we need to decide where the other numbers go. So first off, base 2 and base 2 are always the same. You can at least get that number out of the way immediately. Okay, so these are always going to be the same. It's pretty obvious who and where they are. Well, 8 is going to go next to the 2 now, and 3 that was with the 2 now is going to be far away from it. I would kind of like to say they switch positions, but I don't like to just use the word switch so much. I personally say friends, and so 2 and 3 were friends, but they're not friends anymore. They're far away. But 8 was all by himself. Now they're friends. So that's kind of my way of doing it. I make a lot of jokes about this in class, but I'm not going to do all that here because they're time-sensitive jokes. That's what they are. I would not want to say that this style I can say, oh, look, the 3 and the 8, they switch. No. Don't do that because what you're going to end up doing is you'll get a different problem that looks kind of like this all of a sudden. You got your base, and you're like, oh, hey, they switch. No, they don't. That would be an actual. This here they do actually do. I guess you could say switch, whatever. I don't like using that. But here this would be completely incorrect. Don't do that at all. It's just it's a position thing, and that's why I like to say friends because again, we have 2 and 3. They're friends, but they're no longer friends. They're really far away. 8 didn't have any friends. Now he's got a friend with 2 friends. It's pretty simple. That's how I do it. Let's keep going. Okay, so that's how you convert back and forth. 2, 4, 2, 3. Here we go. I got 3 is equal to log base 5 of m. And they say rewrite in exponential form. This should be pretty easy because first off, let me use a different color here. We got our base. And then I got these 2 positions here. So I want to know who's next to the 5 base and who's far away. Well, 5 and m were good friends, but no longer. M is now far away. Well, 3 was all by himself. Well, now he's got a friend with the 5. There you go. That's literally your answer. You just type that in, you're done. You don't need parentheses. It should be fine without that. 4, 2, 7. Log base 2 of 8 is equal to y. Rewrite in exponential form. And so my base is 2. Go ahead and set it up. And then I say, okay, well, what goes where? Well, 2 and 8 were friends. No longer. Y was by himself. Now he's got a friend with 2. There you go. Very simple stuff. Again, you don't need those parentheses. I'm just using them as the setup. They help me to see what I should be doing. 5 squared is equal to 25. True! Write it in log form. So then I got log base 5. Again, you always start with your base. That's easy. And then you set it up. 1's close by and 1's far away. 2 is now far away, and 25 is now closer. So there you go. I'm just thinking about all the jokes I normally use in class, like in lecture classes. It's okay. I mean, yeah, they're funny. You can email me if you're really concerned about, like, hey, I want to really know those jokes. Then I guess I can give you a couple jokes on my email. Okay, some of these questions are super easy, and they're kind of fun. They say log base 3 of 3 is equal to what? So what I do, just as this is me, I say, there's my base, and I set it up, okay? And so 3 and 3, they were good friends. I mean, heck, they're like twins, but no longer. You're way far away now. Over on this side, I literally have a box. And so I say, box, he was all by himself. Now, 3 and the box are friends. What you've set up is 3 to the something is equal to 3. What goes in the box? What's the power here that makes sense? Well, 3 to the 1 is equal to 3. So your answer is 1. You just put a 1 right there. There's actually a lot more to it, but that's one of the ways. Another one, which we'll see pretty soon, is that the 3's cancel and make a 1. Very simple. I wouldn't do that every single time, but that is definitely another way to do it. I got log base 3 of 81 is equal to what? So let me do this the long way, and then I'll ask a question. So let's start with my base. My base is 3, and I'm going to set it up. So 81 was a good friend. Now you're far away. Got my box. Box is now a friend with the 3. Again, I'm setting this up. 3 to the what power is equal to 81. Well, on the side here, 3 to the 1 is 3. Oop, sorry. 3 squared is 9. 3 cubed is 27. Ugh. 3 to the 4th is 81. Oh, that's it. 4. So 4 was in the box. And that's your answer, just 4. Just put a 4 in the box and you're done. That was easy. So let me just go and ask you a question. Now that we've had this here, I'm going to ask you 3 to what power is 81? Go down the list. 3 to what power is 81? 4. So that's your power. Just another thought there. You don't have to keep setting it up. You don't have to keep doing whatever. You don't have to cancel. You don't have to whatever. Just 3 to what power is equal to this guy? Okay. Just another thought. Not required. Okay, I got log base 11 of 1 over the square root of 11 is equal to what? It's no coincidence that you have an 11 and 11. That is going to be helpful to us. I'm going to set this thing up. I got my 11, and to the power of box is equal to 1 over the square root of 11. I basically just rearranged it like I normally would. I'm wondering what power of 11 makes this thing work. And so what I'm going to do is try to simplify this guy down a little bit. First off, I see a fraction. And so a fraction means a negative power. Hey, square root. What's the square root power? It's a half. Square root is a half power. And notice powers of powers multiply. So half times negative 1 is negative 1/2. So what you're saying is 11 to the box is equal to 11 to the negative 1/2. Guess what's in the box? It's negative 1/2. Yay! Stars. Okay. That was just, it's not a hard problem. It looks intimidating. It does. It looks intimidating. But you got your square root, which is a half. It's a fraction. Make it negative. Done. All right. 4 to 37, one of my favorites here. I got log base 4 of 1. Now this one's a little bit strange. I'm going to write this one out. I got 4 to the box is equal to 1. What goes in the box? Well, okay, let me try the 4 to the 1 is 4. 4 squared is 16. 4 cubed is, I think it's 64. But I don't feel like I'm getting anywhere because I need a 1. What if you went backwards? 4 to the 0 is equal to 1. Anything to the 0 power is equal to 1. That's it. Cool. And it doesn't have to be a 4. It could be any kind of base. And log of 1 always equals 0. Okay. 4 to 39. So then this one says log base 3 of 3 to the 8th power is equal to what? So here's some tricks here. The 3's cancel and you get an 8. Ta-da! I mean, you could do the math and set it up, but that is what's going to happen. And I'm going to keep on teaching that way because it's super easy. 8 to the log base 8 of 3. The 8's cancel, leaves you with a 3. Boom! Super easy. We like these problems. Again, how do they cancel? I mean, you can do the same setup as normal, and you'll just see the same kind of idea. Okay. So 4 to 47. This guy is a lot. It's a matching problem with graphs. It's log base 4, by the way. And again, I'm being so blasphemous by using f of x for every single one of them. Ugh, not even my math lab would do that. And that's a computer. It's not even a human. Yeah, okay. And sorry for my sloppy handwriting. I mean, you pull up the homework, you could see it. It's only this one question, really. I just want to kind of get you started on what to do here. So we got a whole ton of logs here. We can make a forest. Ha 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 ha. Logs, timber, wood, forest. Okay, moving on. Okay, so this is my basic one right here, and log base 4 would look like this. Okay, so that's my basic one right there. It's crossing through at 1. Way over here, we got 4 comma 1, whatever that number is that can go right there in that spot. Cool, so we got that guy. Well, notice that this is the same problem, but it's shifted down by 1, and so it looks kind of like this. Very hard to see, but here it'll be shifted down at 1, 1, I believe. Negative 1, 1, something like that. Anyways, so it's shifted down by 1. I know that doesn't, it looks like it's maybe shifted to the side. It's just down. This is shifted to the right by 1. Again, very difficult to kind of see, except that you have a new vertical asymptote right there. So it's shifted over by 1. This one's flipped sideways, so it goes this way now. This one's flipped upside down, so it's going like this now. And then finally, this guy is, I don't really know. Well, let me rewrite this like this. Notice that it's flipped upside down and it's going up 1. So it still looks like this because it's flipped upside down, but it's been shifted up by 1 as well. Okay, so just, I don't know, do your best. Some of these are really tough to kind of see. We just get by and keep on cruising. Next question. I got 4 to 75. So they say g of x is equal to log base 6 of x plus 5. And they want to know what is the domain of this function. Okay. Well, I could definitely give you the math side of things, but I just want to see, we're shifting this to the left. It's a shift to the left by 5, so I got, my original was right here. I'm going to go 1, 2, 3, 4, 5. That's my new vertical asymptote, and I just go right here through that 1. There you go. So they say, what's the domain of this graph? What's the domain of this function? Oh, guess what? 5 is an important number. Yep, it's an important number. Notice that I'm starting basically at negative 5, and then I go on towards infinity. The thing is that I'm not actually touching the 5 right there. It's a vertical asymptote, and so I'm not actually touching 5. I'm just going to get really close to it and then go on towards infinity. How do I, oh yeah, how do I find that otherwise? You could just take the inside and solve for x, by the way. Take the inside equal to 0, solve for x. There you go. Again, that's a vertical asymptote, but it's the start of your graph as well. Okay, 4281. I got log 100. Now, I'm already seeing some kind of issue here. The reason why is because it doesn't have a base. What's its base? Well, whenever there's a missing base, the base always then equals 10. So what they're wanting to say is log base 10 of 100. It's called the common base. Common base. And why 10? Because you got 10 fingers. That's why. Literally, I'm not kidding you. So let's figure out what this is like. What is this guy? What is this guy? Well, for one thing, you could just use a scientific calculator, and you can. They all have this button, log 100, log, and then you type 100 and you hit enter, and you're going to get a 2, and that's pretty easy. Another way is that you can see this as log base 10 of 10 squared. Notice that 100 is 10 squared, and I did that so that the 10s cancel, leaving it with a 2. So either way, quite okay. There's obviously other ways to do it, but that's good enough for now. That's supposed to be an 89. I don't know why I put a dot right there. Not 89, it's 89. Okay, I got ln of e to the 5th power is equal to what? Now hold on. Whenever you have an ln, if you were looking around for a log button on your calculator, cool. You probably also saw the ln button. Ln, it stands for log natural. Logarithm naturalis, I guess, because it sounds French. Good enough. So ln. But what it is log base e and of whatever. So log base e, if there's an ln, what it's trying to say, like what you're really wanting to say here, is log base e of e to the 5th. Now this makes it super easy because the e's cancel and make a 5. Later on, you'll also basically just say ln and e always cancel one another. So either way, I'll just go ahead and do that. That's good enough. Okay, cool. So that's good. Gosh, there was something else I wanted to talk about. Log base e. It's definitely in your calculator. It cancels with this guy. Okay, well. Oh, yeah, and natural. It's the natural base. Natural base. There you go. Okay, so I definitely want to talk about one thing here. This is a very important topic. Okay, let's just pause for a second here, okay? The font on my math lab, the font on your browser is not the best for math always. And so whenever you're doing these ln problems, they do ln like this, which looks incredibly like this guy, which is in. It is not in, it is ln. ln, that's a lowercase l, it's not a capital I. It's not in, it's ln. Your font just makes it look weird. I don't like this. That's just what my math lab, your browser, everything's it's going to look like that, sadly. It needs a lot more hook, is what it needs to make it look like an L. And so this is where you could get a lot of issues. So if you're watching this video, please do not type I's into your boxes for your answer. Like it'll say, hey, the ln2 is your answer. And if you type in2, it's not going to work. So please don't do that. Type in ln. I know it looks kind of weird. It should bold. Like as soon as you'll type the L and then you type the N and it should bold. My math lab is saying, ooh, I understand you. Okay? So, and then you can just type your 2 and it's going to be great. Okay? So if it's not bolding, if something's not working, of course you can always ask me, send me a question or something, but this is a very common mistake that I've seen. People will call it IN. I don't know why. I mean, I'm on my lectures calling it log. It's in the log section. It's log natural, and that's why it's LN. So definitely L. Okay. Now I'm done. Now let's actually keep going. It's a very common thing. I get this every semester. I just want to make sure to make a point about it. Okay. Log base 3 of x minus 3 is equal to 4. And solve for x. Solve for x. Yeah, I don't know how to do that. It's a joke. It's a joke. So, okay. I got my base of 3, and then I'm going to set it up. Well, 3 had a friend here with x minus 3, but no longer. He's really far away now. 4 was all by himself, but now he's got a friend with 3. Again, they're just kind of moving around friends-wise and all that kind of stuff. What we've done here is created a whole new problem. I got 3 to the 4th, so that's 3, 9, 27, 81. And then it's equal to x minus 3. Solve for x. Add 3 to both sides, obviously, and we get 84 is my answer. So what you want to do is just rewrite it into a exponential form which we understand. I do not understand logs. I teach this stuff, and I can't tell you what the answer is. Solve for x. I'd just sit there saying, I don't know. But if I convert it over to exponential, now I'm happy because I understand that. We all understand exponentials. That's the point here, okay? Now, my math lab's a little funny about this problem. What they want is this right here for part A, and this guy here is your part B. I don't know why exactly. They'll probably tell you, convert it to exponential or something, which we were going to do anyways because we're studious students. So 42105. I've got log base 2 of log base 8 of 8. Now, this one's just strange to me. How can you have a log of a whatever? I don't even know how that's applicable to anybody. But, hey, it's a math problem on your homework, so let's do it. Well, first off, the 8's cancel, and you're like, okay, we're done. Whoa, 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 whoa. It cancels to make a 1. Cancels to make a 1. And log of 1, it does not matter what base it is, log of 1 is always equal to 0. Always. Well, there you go. We're done. Let's do something else that's similar. 42107. I got log base 4 of log base 2 of 16 is equal to what? Well, there's no canceling here going on. What I could do is I can say, hey, 2 to what power is equal to 16? Or I could rewrite that as log base 2 of 2 to the 16. Is it 4? 2 to the 4? 2 to the 4th. Either way, the 2's are going to cancel, leaving you with a 4. So now I've got log base 4 of 4. Well, those 4's cancel, leaving you with a 1. That's your final answer there. Okay, 42109. I got f of x is equal to ln of x squared plus 6x minus 7. And they say find the domain. This one's actually a little bit longer problem. I'm going to say set the inside equal to 0. And then let's start solving. And what we're doing here is we're trying to find vertical asymptotes and stuff like that. Basically, do you remember? You probably remember. Hopefully you remember. Back in Chapter 2, we were doing a section with domains. And I would say, hey, do we have division? And you would say yes or no. And hey, do we have a square root of a negative number? And you would say yes or no. And so I would say the bottom equals 0, the inside equals 0. To go and solve for domain issues and stuff like that. So these are great questions. I'm going to ask them, do we have any division? No. Do we have any square roots? That's a square. That's not a square root. So no. Do I have a log? And the answer is yes, I have a log. And so what I need to do is set the inside equal to 0 and start solving. So let's do that right now. Okay. So let's see here. We got, we can factor it. What two numbers multiply to make a 7, but yet they add up to a 6? Very good. 7 and 1. So I got a plus 7 and a negative 1. And so then I can solve for x and I can say, oh, I got a negative 7 and a positive 1. Again, these are vertical asymptotes. on my domain stuff. I do not want to actually include them or anything like that. But at the same time, I want to see where the graph actually works. And so I'm going to just do a whole new thing here. I'm going to do a number line from negative infinity all the way to negative 7. Here's a 1 off to positive infinity. And I need to test some numbers in between here to see where my domain exists. Pick an easy number that's less than negative 7, something more negative than negative 7. Very good, negative 8. Okay, so plugging that into the very first original, this guy right here, I got ln of negative 8 squared plus 6 times the negative 8 minus the 7. Yep. Actually, I'm going to put this in the calculator just as you see it. I didn't pick that on my notes, so I actually have to do this, if that's okay. So, ln button. Heck, on my on my calculator, ln looks like in. Oh my goodness. Font. Tell you what. No, that's just a negative there. And we got a minus sign. And I got 2.19722. Awesome. Notice that we got a number. It works. Yay! Okay, pick an easy number between negative 7 and 1. Oh, I don't know. What about 0? That's an easy one. So I'm going to plug in 0. 0 squared. 6 times 0 minus 7. I'm going to type this thing in right quick. I'm going to see what my my cool Casio 115 does. Oh, it says math error. Wah, wah, wah. That ain't going to work. Okay, what's an easy number that's more than 1? 2. Plugging it in. You get the idea here. And, well, it works. Okay, great. So, I don't know. Just it's a number. Oh, actually, I do have that number. It's I wrote that one down, 2197. So, there you go. Wow. Did I get the same number twice? That's kind of weird. Whatever. Okay, cool. So it doesn't really matter. It works. That's all I care about. You do not want an error. Error, bad. Negative, positive, doesn't matter to me. What if I got a negative? I don't care. That's fine. Do I get a decimal? I don't care. That's fine. I just don't want it to error. So this is good. This is good. Nothing in between. So what's my domain? Negative infinity over to the negative 7. Go around all that area. Go around it. And then you're going to go from 2 to infinity. And there you go. The end. Okay. Oh, wow. I only have one more question left. So nice. So I got 42117. This is about decibel levels. I got 10 times log of 10 to the 12th power times I. I stands for intensity. And they're talking about decibels. About an animal that's 500 miles away. So, okay, I have this animal 500 miles away, and it's making a sound, it's making its call. And they say the intensity is 2.8 times 10 to the 4th. That's my I. I'm going to just plug that guy in. And so they say, what would the decibel level be here? So 500 miles away from this animal, I don't know what animal it is, and apparently it makes its cry, it calls out, what's the decibel levels that I hear in my ear? And so I'm going to plug that in. This is all just calculator. Now this times 10 to the whatever, I just literally put it times 10 to the power 4. It doesn't really matter. There's special buttons to do all that. I don't really care. Just type it in, and you got 164.4715 decibels. If you know anything about what decibels is, this is loud, okay? Not just loud. It even says on the problem that 160 decibels ruptures your eardrum. So some kind of animal 500 miles away, yells out, and it's not just that you can hear it, but it's so loud that it ruptures your eardrum 500 miles away. And notice again, it's just 4 decibels over. You're going to say the word. Yes, it does rupture eardrums. So just imagine standing right next to this thing. What could be this animal? Think about it. Not a lion. It's a whale. It's a whale. And so you'd have to be underwater, I think, to be able to hear it. Okay, that was enough. You have a great day. Thanks for watching.